A warm welcome to viewers. Under strength of material subject, civil engineering subject, let us learn about the first chapter, Introduction to Engineering Mechanics, for session 1. What is mechanics? Mechanics is a branch of science which deals with the behavior of a rigid body in rest or motion. Why we study mechanics? By studying mechanics, which will help further study in the design and analysis of structures like beam, columns, slabs, etc. Major part of engineering mechanics are statics and dynamics. Under statics, it is a branch of engineering mechanics where we study the behavior of a body at rest, and in dynamics it is also a branch of engineering mechanics where we study the behavior of body in motion. The four fundamental quantities in engineering mechanics are mass, length, time, force. In session 1, we'll try to learn about the force, characteristics of force, resolution of forces, and finding the magnitudes of the resultants. Here a typical diagram of engineering mechanics. As I told you, there are two major parts in the engineering mechanics: statics, where we study the behavior of a body in rest, and in dynamics we study the behavior of a body in motion. Again, as I told you, statics and dynamics. Under dynamics, they are again subdivided into kinematics and kinetics. What is kinematics? Here we consider the forces which causes the motion are not considered in the study of a body in motion, and in kinetics, forces which cause the motion are considered in the study of a body in motion. The major difference between those two, kinematics and kinetics: here in kinematics we don't consider the forces, in kinetics we consider the forces, and both kinematics and kinetics which come under the sub part of dynamics. Dynamics, again, it's a branch of engineering mechanics where we study the behavior of a body in motion. As I told you, the major four quantities in the engineering mechanics: time, length, mass, force. Let us take the force. Force is the action of a body on as push or pull. So you can see in this diagram here pushes and pulls, where we can see the displacement of a object. Coming back here, now push at A and pull at B. Let us see in the other diagram. A is the tail and B is the tip, as in the figure, and force is a vector quantity. Now, as I told you, A is a tail point, B is a tip point, and here we can see the magnitude 100 Newton, which is acting in the direction, and direction is given by east 45 degree north, and these are the characteristics of force. What is the characteristics? First one, magnitude, direction, line of action, point of application. Let us learn once again. Magnitude of 100 Newton, see here in the diagram, the magnitude of 100 Newton acting with the direction, okay, and with the direction, what is the direction is given? East 45 degree north, okay, that is the direction. We can see here four major characteristics: magnitude, direction, line of action, and point of application. Where these points are conducting at C, at point A, which is the tail, the bottommost point, there the point of application we can observe there, that is one of the characteristics of force. Line of action, there is one more characteristic of a force, and magnitude of 100 Newton with a direction of 45 degree. Now we studied what is a force. It's a push or a pull which causes the motion of a body, and we have studied the characteristics of a force, that is a magnitude, direction, line of action and point of application. Now coming to the system of forces. Force system, there are majorly two types. One is a coplanar and non-coplanar. And a coplanar, the first one is again the coplanar is subdivided into collinear, parallel, concurrent, non-concurrent. Under non-coplanar, parallel, concurrent, non-concurrent, there is no collinear in the non-coplanar system of force. Majorly two type, coplanar and non-coplanar. In two or more force act on a body, they are called a system of force. When two or more, that is one or more than two apply on any plane or any double plane, and that system we can call it on the body, we can call that as a system of a force. As I discussed in the previous slide, different system of force are coplanar force system and non-coplanar force system. Okay, let us take the first one, coplanar force system. Force whose line of action lies in the same plane are coplanar and non-coplanar. Under coplanar, the forces whose line of action lie in the same plane. So line of action is a characteristics of a force. Under coplanar, where the force lies in the same plane, we have subdivided, we have four parts: coplanar collinear, coplanar concurrent, coplanar parallel, coplanar non-concurrent, non-parallel. So moving further, as I told you, the coplanar force system, where the forces of a body which lie in the same plane means you can see here the xy coordinate and the line of action. See again, as I told you, the line of action is characteristic of a force. They lie in the same plane. You can observe in this picture. Moving further, the various types of force systems, as I told you, coplanar, non-coplanar. Coplanar, picture A, B, C, D are the typical examples of a coplanar, and E, F, you can observe there non-coplanar, E and F pictures which the mention about the non-coplanar force system. First one, as I told you, coplanar collinear. You can observe there the forces F1, F2, F3, they lie in the same line of action, and in concurrent all the forces F1, F2, F3, they meet at a common point. You have to observe that point. Okay, concurrent, they meet at a point or they come out from the point. And the third, you can see both characteristics, both types of system in the coplanar, where it is concurrent and also collinear. Concurrent means common point, and collinear, the line of action is in the same line. See the picture C, coplanar parallel forces, where the forces may be not in the same direction, in the different directions, they are parallel to each other. And there is one more example for the coplanar. Again, it is in the form of a beam, typical beam section or the line diagram of a beam. The forces or the weights W1, W2 and W3 act on the supports. Here RA and RB are reactions or the supports. As I told you, the other system of force is non-coplanar, and which does not lie in the same plane. You can observe X, Y, Z. Okay, that is non-coplanar concurrent forces. Concurrent forces means they meet at a common point. They meet at a point or they emerge from the common point. See the difference between coplanar concurrent and figure E, non-coplanar concurrent. Here in coplanar concurrent you have only one plane X and Y, and in diagram E, non-coplanar concurrent, where they meet at a common point X, Y, Z. F, coming to F, non-concurrent, non-parallel. It applies to both coplanar and it applies to coplanar. Here neither they are parallel, they are not meeting at a point, or they are not coming from the point. Let us study one by one. As I told you, coplanar, under coplanar, collinear, concurrent, parallel and non-concurrent, non-parallel. These are the system of forces. These are the subsystem of a coplanar system of force. First one, coplanar collinear. Forces F1, F2, F3 which act in the same plane. That is the major explanation of a coplanar system, how you explain. Where the forces F1 and F2, F3 act in the same lane. You can observe F1, F2, F3, they are in the same plane. It's a single plane, maybe XY. And the third point of that, F1, F2, F3 having a common line of action. Line of action is the characteristics of force. What are the characteristics of force? Magnitude, direction, point of application. Point of application is where we apply the force from the point A, that is a tail, and line of action where it continues with the after the point B, that is tip of the force or arrow. Coplanar concurrent, the second one of a coplanar concurrent. As I told you, F1, F2, F3 act in the same plane. F1 and second one is F1, F2, F3 meet at a common point. Meet at a common point, and F1, F2, F3 acting in the different directions. You can observe there the common point. The difference between collinear and concurrent. Collinear, line of action, having common line of action and act in the same line. Here they have all the forces, they meet at a common point, and you can see the direction, different directions. Coplanar parallel, that is the third system of force in the coplanar. Here as we know, F1, F2, F3 act in the same plane, and F1, F2, F3 parallel to each other. First one, they lie in the same collinear, they lie in the same line. Concurrent, they meet at a common point. Here all the forces parallel to each other. And the third one, F1, F2, F3 acting in the same direction or in a different direction, but they are parallel to each other. And again, parallel, coplanar parallel subdivided into like parallel forces and unlike parallel forces. Like parallel, where all the forces having the common direction or the same direction. Unlike parallel system, act in the different direction, as we can observe in the diagram or a picture. The fourth and last part of a coplanar force system, forces F1, F2 and F3 act in the same plane. And second point, F1, F2, F3 not parallel to each other, and F1, F2, F3 act in a same or different direction and does not meet any common point or same point. Here the first three, that is collinear, concurrent, parallel, any of the they don't match up with the first top three coplanar system of force. Neither they are in the common line, they don't meet at a common point, and they are not parallel to each other, and the fourth one is called as non-concurrent. Okay. The second major part of force system, as I told you in the earlier slides, okay, coplanar force system, you have non-coplanar force system where the forces whose line of action does not lie in the same plane. Again, it is having subparts: non-coplanar concurrent, non-coplanar parallel, and non-coplanar non-concurrent or non-parallel. So as per our curriculum, we are not going to study about the non-coplanar system or force system. This is a typical diagram or the pic of a non-coplanar force. Here we can observe in non-coplanar that which the forces does not lie in the same plane, different plane. Here we don't observe XY coordinates. Okay. Now coming to the resolution of forces. So earlier we studied about the force, definition of force, characteristics of force, that is magnitude, direction, line of action, point of action. Okay, point of application.